Calculus video 4, example 2, using the limit definition of the derivative. This time my example is f of x is equal to the square root of x plus 1. Let's see what happens at the value a equals 3 or x equals 3. Sometimes we'll use, instead of x equals 3, letters like a equals 3 or c equals 3 just to designate we want it at this particular point. So what would the y value here be at a equals 3? F of 3 is equal to square root 3 plus 1. That is the square root of 4. That is 2. So what we're looking at is the point 3, 2. And so we have the graph of the square root of x plus 1. So that is the graph of the square root of x moved to the left by 1. Right, x plus 1 moves it left by 1 at the point 3, 2, right about there. And what we want to know is what is the slope of the tangent line, and maybe even what is the equation of that tangent line there in orange. To do so, we'll use the limit definition of the derivative, which gives us the slope at any point on the curve, square root of x plus 1, which I've written off to the left as the limit as h goes to 0, f of x plus h minus f of x over h, and the notation we use for that is f prime of x to denote the derivative. All right, well, we know that f of x is the square root of x plus 1. The question is, what is f of x plus h? Well, we will, every time we see an x, plug in an x plus h. In this case, we see there's no real reason for those parentheses around the x plus h. And so we have this square root of x plus h plus 1. That part wasn't too hard, but we'll see some additional difficulty when we try to do some cancellation. So f prime of x is the limit as h goes to 0 of f of x plus h, square root of x plus h plus 1, minus f of x, square root of x plus 1, over h. And if you remember, here's why I said earlier videos, oh, every time we have every term in the f of x, we'll cancel that with something from the f of x plus h, which is true in a polynomial, and will eventually be true here, but we have some problems in that I can't cancel things inside the square root of x plus, inside the square root here, x plus 1, with the x plus 1 on the left side, that square root, it's not the same thing. You can't cancel the insides of the square root, so we need to do some algebra. All right, so let's put our algebra thinking on, and how do we make this where, change this to where we can actually cancel things out. The issue here is I have the square roots. It would be nice to be able to get rid of those square roots. And algebra can save us by taking this entire fraction here and multiplying it top and bottom by the conjugate of those two terms in square root. Now the conjugate, remember, you keep the first term the same sign, but you change the sign to the second term. So we have the square root of x plus h plus 1. That stays exactly the same. Instead of minus here, though, I have plus square root of x plus 1. And because I don't want to change the entire problem, I want to multiply here by 1. So multiplying by 1 does not change the problem. We do this a lot in calculus, and so we multiply by the exact same thing in the denominator. Therefore, it's just like multiplying by 1, because these two terms would be able to cancel. But don't cancel them, because the idea here is I want to distribute within the numerator. One thing of note here to help is keep the denominator not distributed. In other words, don't just try to distribute the h into the denominator, because remember, when we do these problems, we want to cancel out that h eventually, so we're just going to leave that h by itself. So what I'm going to do now is I'm going to take distributing in the numerator, like so, and I would get the limit as h goes to 0. The square root of x plus h plus 1 times the square root of x plus h plus 1 is simply x plus h plus 1. The square root of x plus h plus 1 times the square root of x plus 1 is the square, I'm going to need a bigger line here. The square root of x plus h plus 1 times the square root of x plus 1. That's okay, because look what happens next. Minus square root of x plus 1 times the square root of x plus h plus 1. What happens to those middle terms there? We have a positive square root of x plus h plus 1 times square root of x plus 1 and a negative square root of x plus 1 times square root of x plus h plus 1. Those two terms will cancel out. Okay, but let's finish multiplying before we do that. We have this last one in orange here. Negative square root of x plus 1 times positive square root of x plus 1 is minus parentheses x plus 1. So we see that the two middle terms cancel out. Oh, I forgot my h. Divided by h. Divided by, h times, don't distribute here, square root of x plus h plus 1. Plus the square root of x plus 1. Just leave that in parentheses in the denominator. Okay, so my two middle terms here will cancel. And then, let me just rewrite because I have a lot of stuff going on here. The limit as h goes to 0 of x plus h plus 1 minus x plus 1 in parentheses over h square root x plus h plus 1 plus square root x plus 1. We see now the x plus 1 in parentheses in the numerator have an x here minus x there. Those two will cancel. I have a 1 minus 1. Those two will cancel. And all I have left in the numerator is h. Okay, h over h cancels. Now when you cancel an h, it's all that's left there. It's not 0 on top of it, it's just a 1 left over. So that's equal to the limit as h goes to 0 of 1 over square root x plus h plus 1 plus square root x plus 1. Now let's let all the h's get close to 0, as close as they can be, so we'll just let them go to 0. It's 1 over square root of x plus 0 plus 1 plus square root of x plus 1. X plus 0 plus 1 is x plus 1, so in the denominator here I have 2 square root of x plus 1s, and that is my derivative. The derivative of f of x, f prime of x, is equal to 1 divided by 2 times the square root of x plus 1. Again, this is the function that tells us the slope of the tangent line at any point x that we want on our original function, square root of x plus 1. So we had an original function of f of x equals square root of x plus 1. We now know the derivative. What we want is the slope of the tangent line at a equals 3, or x equals 3 if you want to use x instead. So we want f prime at a value of 3. That is 1 over 2 times the square root of 3 plus 1. 1 over 2 times the square root of 4. That's 1 over 2 times 2. That's 1/4. And what we're saying here is the slope of the tangent line at the point, was it 3, 2, I believe. At the point 3, 2, the slope of the tangent line is 1/4. Let's see if that makes sense in the drawing. Yeah, it's not the best drawing in the world, but I'd buy that you go up 1 over 4 with my rudimentary drawing. Okay, now finally, what is the equation of the tangent line? The equation of the tangent line sorry about that. The equation of the tangent line, y minus y1, equals m times x minus x1. That would be y minus 2 is equal to positive 1/4 times x minus 3. Make it a little bit of fractions here, but that's okay. Y minus 2 is 1/4 x minus 3/4, distributing the 1/4. Adding 2 to both sides, add 2. We get y equals 1/4 x let's see, that'd be 1 1/4 left over, or if you want to write that as 5/4 or 1 1/4, either way is fine. Or if you want to use decimals, I'm okay with that. Y is 0.25x plus 1.25. You know, whichever one makes you happy on the equation of the tangent line. Let's see what that would look like in Desmos real quick. Let's go over to Desmos. We have our curve here, f of x is the square root of x plus 1 at the point 3, 2. Let's go ahead and plug in our tangent line. Y equals 1/4 x plus 5/4, and yep, that looks like a good tangent line. Quick note, up here I have in the function f of x, x equals the square root of x plus 1. If you're a little bit new to Desmos, to use the square root symbol, if you just start typing in SQRT, it turns into a square root, and then you can do x plus 1 like that.